Continuing on with some verifying trigonometric identities. We have 23 here, and our left side's more complicated. I do see a 1 with a squared function. There's a couple different ways to go about this. What I would probably do, I see a 1 with a sine squared, so can I change this one into a form of that has 1 and sine squared? Well, what I could do is I could subtract sine squared from both sides from this highlighted one, and if I subtract sine squared from both sides, I get cosine squared is equal to 1 minus sine squared. And so up here, 1 minus sine squared is simply equal to cosine squared. So I can use a form of one of my trig identities, my Pythagorean identities, and change 1 minus sine squared into cosine squared. And now hopefully we start realizing that this is going to work out well. In my mind, I'm thinking, oh, secant is equal to 1 over cosine theta. That's just what I'm thinking. And then over on the left, I see, oh, well, I can reduce and get that 1 over cosine theta. So 1 over cosine theta does equal secant theta. And for some reason, I'm rewriting secant theta on the left, right side a lot, but now using the reciprocal identity, we get that they are equal. So what did we do here? I didn't write all of my reasons, which we don't have to in trig identities, but the first thing we did here was we used a Pythagorean identity. It was a form of the most well-known one. And then we simplified, reduced, canceled, whatever term you want to say. I believe simplified is the best way to say it. So we simplified, and then we used a reciprocal identity. All right, 25. 25, we have cotangent over 1 plus cotangent squared equals sine theta times cosine theta. I would say the left side's more complicated. I do see a 1 plus cotangent squared, and when I see a 1 plus a squared, I do like to think Pythagorean, and actually right here, we have a cotangent squared plus 1. So let's go ahead and change that denominator to cosecant. So let's say this is cotangent theta, leaving the numerator the same, over, using the one I just boxed in with orange, this is secant, sorry, not secant, it's equal to cosecant squared theta. And now I'm also noticing the right side is sine and cosine. So let's just try to switch everything to sine and cosine. Before I do that, I'm going to write that I used a Pythagorean identity here. Well, cotangent is cosine theta over sine theta, and cosecant squared is 1 over sine squared. So that was we used the quotient identity on top, and we used a reciprocal identity on the bottom. We now can multiply both top and bottom by sine squared over 1 to simplify a compound fraction. And cancels here. One of these cancel. We are left with cosine theta times sine theta, and just in time because we're out of room. So we have cosine theta times sine theta, which is what we wanted. And that was just simplifying. Okay, let's look at this last one, number 27. Left side looks more complicated. Again, I'm going to try to I know I just give you these little snippets of ideas here and there. Hopefully they're starting to make sense and you see them. But on the right side, which I would say is the less complicated side, there are two terms. On the left side, there's just one. However, there is a denominator, so we could actually split that denominator into, so we have two fractions. And I think if we do that, it actually is going to really work out quite quickly here. So what I'm going to do is I'm going to use this denominator and put it under each term so that we have a common denominator that we're separating it into two fractions. A lot of times when adding, we combine things into one fraction. When we have one fraction, we're going to separate it into two. And when we do, we probably could even not write all these steps, but I'm going to go ahead and do that. So we have sine theta, our first part, over the common denominator. And automatically, or right away, we see that's going to cancel. And then over here, we're going to do the same thing. We're going to have cosine theta over that denominator. And cosine will end up canceling, as we can see. Sometimes you start noticing things and you have to just finish writing before you can go to the next step. Like in your mind it's going, but you have to write it all down. The next step then, we saw that they cancel, so this is 1 over cosine plus the cosines would cancel, so that'd be 1 over sine. And keeping in mind what we're trying to get to, secant theta plus cosecant theta, that's our goal. Well, just use reciprocal here. So we did common denominator, we canceled or reduced or simplified, and now we're going to use reciprocal identity. And we have what we need. We have secant theta, 1 over cosine theta is secant theta, plus cosecant theta is equal to what was on the right side.